All right, this is a good one. This Russian cosmonaut, she's outside for a spacewalk. She's floating 15 meters away. Doesn't seem like we would need that right now, but maybe later. She's basically out in the middle of space by her spaceship she gets severed. So she's floating there. She's not able to walk back to the ship. She's floating. So she tosses her 2 kilogram camera away from the spaceship with a speed of 12 meters per second. They want to know how fast, right? If you throw something forward, it will push you backwards since we're out in space with no friction. You're going to go backwards. So she throws it opposite the way she wants to go, and you throw the camera throws you, she's going to travel back to the spaceship. So this is basically an explosion, right? A 1 to 2. And if we know anything about these right now, I'll just write it out. M1 plus M2 V initial equals M1 V1 final plus M2 V2 final. Our initial velocity before she throws this camera is 0. So 68 and 2 is 70 kilograms. I'm doing a little fast math here. She's going 0. Before she throws the camera. We'll say she is M1 at 68 kilograms. We want to know how fast she's going backwards. The camera is 2 kilograms. And we know it goes away from her at 12. She throws it at 12. You better throw it pretty quick. That's gone. Bye-bye. And then I'm left with this stuff over here on the right, which we did one of these in class, and I told you how much I admire these. Algebra and physics just come together in just blissful harmony, is awesomeness. I have to subtract the 24 from both sides. 24 kg ms equals 68 kg v1f. You wouldn't expect her to be going back as fast. This negative means she's going to be going backwards, yes? Let's divide this 68 from both sides. Bye-bye. Hello to this side. 24 divided by 68 is a small number. It's 0.35, but don't forget your negative sign. That would be meters per second is V1F. Woo-woo. All right, this one asks us how long will it take her to... Whoa, that was weird. How long will it take her to get back to the ship? I bet you that's where we needed that other information. So what it said on... I should have pasted the whole question again, but I didn't. She's 15 meters away from the ship. Hey, my wife's home. Everybody say hi, Laura. Hi, Laura. All right. So velocity equals distance over time. Time equals distance over velocity. We have a distance of 15 meters and a velocity of 0.35 meters per second. Throw that in your calculator. And you should get about, 42.9 seconds. Seems like a long time when you're out in space, almost meeting your demise because your rope got cut from the ship. But 43 seconds later, you're back. Yay! Bye-bye.